Yeah. Good evening, everyone. So, again, let's start off. We are starting off with a new chapter, fluid mechanics. The last time we are done with SHM. Where are the restaurant? Join fast. Hope everyone started solving SHM. Start finishing it off. At least try to wind it up by next, Wednesday. Don't delay it too much because you have to start fluid mechanics from next week again. This is how it will go. Every week the chapter will keep going ahead. Yeah, cams on everyone. So what is this fluid mechanics? So let's start with the definition. Fluid mechanics chapter, right? It is we'll first finish off fluid mechanics, then we'll do gravitation and electrostatics. Because gravity and electrostatics, both are actually quite related. It will be more easy to relate them, and it saves us some time there. So fluid mechanics chapter, right? If you see, kind of, it looks like laws of motion only.
Sir.
Drawing free body diagrams and everything. What happened?
So what to do? Gravitation we will do after this, no?
Huh. Why bol raha na? You just joined, yeah?
Yes, sir.
So let's see. Ideal fluid. So what's an ideal fluid? Any substance that cannot withstand tangential force. To the surface. Pretty simple definition, but it's a very powerful thing. This is technical term for this is called shearing stress. The tangential force to the surface is called shearing stress. We'll be doing this in elasticity chapter. So what do you mean by this exactly? Imagine you have a stack of books. Let's say you have books on top of each other like this. Now, if you apply force on this, this is what will happen to the books. The books will actually start sliding. Isn't it? And if you look at the forces on them, so if you're pulling this with F, this friction will be backward, this friction will be forward, this friction will be backward, this friction will be forward, and so on. So basically, the friction between the books will oppose the motion. So there's an opposition to the motion here. There's an opposition between the layers. This is what actually happens in the normal situation. Now imagine if you take a smooth surfaces, what if friction is absent? What do you think will happen if there's no friction between the books, and if you try to apply force, what would happen?
It will not.
So what will happen? You'll observe only the top book will move, no? Is that making sense, everyone?
Yes.
There's no friction between the books, and if you still apply force, only the top book will move. Not only that, suppose what if I apply force in the middle? Only the middle book will move, right? So whichever book you apply force, only that book will move. So basically, there is no opposition here. Is that making sense? So that is the meaning of the statement. Any substance that cannot withstand tangential force. If you try to apply a force tangential to the surface, the system will not oppose you at all. It will just go ahead. I hope that statement was clear.
So the second one will act as the ideal, no?
This is an ideal fluid now. This is similar to an ideal fluid. Clear? Then, now this is an important statement. In an ideal fluid, there is no interaction between the layers. Meaning now, the net force acting on a liquid surface is always perpendicular to the surface. Now, important statement here, the net force with respect to the, calculate the net force with respect to the container. That is include pseudo force. I'll give you some examples, you'll understand. This entire thing, right, is important. What do you mean by this thing exactly? Just have a read that statement once. Shaurya, cam on. Abhiksha, Ammu, cam on, everyone. Clear? Now, see, what is the meaning of this, you know? If you have a container like this with a fluid, and let's say you're applying a force F like this. Let's say somehow you can apply the force at an angle. Then what will happen? This F cos theta here, the horizontal component, this is tangential, right? This will start pushing the liquid this way. Na? The liquid will start getting pushed to the right side. The liquid will keep on getting pushed till the liquid starts, you know, bending like this. At one point, the liquid becomes perpendicular to this force. Is this making sense? Now look at the logic here. If you apply the force tangentially, what will happen? In this books ka case, if you apply force, they will move, right? If you look at this diagram here, this book has gone out like this. But what if I apply force this way, will there be any problem? If you push the books down, will there be any problem? So books don't have a problem if you push them down. They have a problem if you push them tangentially. That means the liquids will keep on moving till the force becomes perpendicular to the surface. Is this making sense? So here the F cos theta pushes the liquid till F becomes perpendicular to the surface. Is that making sense? So let me give some examples. So let's say we have a container like this at rest, and if you put some liquid, how will the liquid be inside the container? horizontal. Why? Because the mg, the gravity is acting downward, and this should be perpendicular to the surface. Suppose we have an incline and you keep a container like this at rest. Now, can you tell me how will the liquid be? If you put some water in this, how will the water look? Like this, now? Isn't it? Water will still look flat only. Reason? mg is still this way. Is that making sense? But what if this is theta and this is smooth surface, and the container is going down with an acceleration g sine theta? Remember the statement here. Whenever you calculate the net force, you have to include the pseudo force. Means, where is my observer? My observer is standing on the container and observing it. So can you tell me what will be the forces acting on the liquid now? 1, mg sine theta. Look at the forces here. mg sine theta, mg cos theta. Agreed? Since you're standing on the container, there will be a pseudo force ma. Everyone agrees? And what is the pseudo force there? mg sine theta, mg cos theta, and the pseudo force is also mg sine theta, because here A is g sine theta. So the resultant force will be how much? mg cos theta will be the net force. And how should the liquid surface be? Perpendicular to the net force. This is the liquid surface. So if you put liquid into this container, how will the liquid be? Like this, na? Parallel to the incline. Why? The net force will be mg cos theta, perpendicular like this. Are you getting the logic? Liquid surface perpendicular to F net. Please check the third example. It's a good one. If a container is accelerating downward and if an observer is sitting on the container, he will think there's an mg sine theta, mg cos theta, and a pseudo force ma backward up the incline. The pseudo force and the mg sine theta will cancel out. So the person on the container will think the only force acting is mg cos theta this way. And we have a definition: the net force will be always, the surface will be always perpendicular to net force. Now, I'll tell you a technical reason why this is happening. See, it's a logical is also. If the container was at rest, the water here will come this way, na? And it will become like this, isn't it? But what if, when the liquid is coming here, the container is also going forward? Isn't it? Because the container also have g sine theta acceleration. What is happening? See, every time the liquid will try to come and hit the wall, the container has already gone forward, na? Are you getting it? Every time you're coming front, the container is also going forward. You're coming front, container is going forward. So it gives you a feeling as if the liquid is always horizontal. You're never giving it time to hit the wall and accumulate. Are you getting it? So ground frame mein wo ho raha tha actually, but it looks little difficult to visualize. Do have a look at this. We are finding net force on the liquid surface. We are not finding on the ground. Liquid force ka ye forces tha. These are the forces on the liquid.
Okay.
Please check out this example. And see, I just taught you one concept till now. The net force is perpendicular to the surface. And with that, we are going to do some questions. Any doubts on these examples? Please ask. Ah, Vrinda, finally back. What happened? Took a big break.
I had a family function.
So make sure to go through the recordings at least.
Sure, sir. Yeah.
I'll upload them by this week, tomorrow or something. And this week has been, next week is NEET exam na, and your seniors ka BITS exam, advanced exam. Some exams aa gaye ek sath. I took doubts yesterday at 12:30. Your seniors are like, they're full on. Abhi last 2 weeks pehle na, they're like God mode. People are studying 14 hours, 15 hours. they are getting lot of doubts. वही है, from the beginning when I shout on ना, अरे boss every day पढ़ो नहीं होता है. Last 3-4 weeks people become gods. So if someone sees Naruto, let's say ना Goku and all that, Dragon Ball Z जैसा super sense बन जाते लोग. So everyone clear with this? Now based on this, we have a question set. You give it a try. What if the same question, theta, we have an container, we have a friction also, mu less than tan theta. So the liquid actually becomes like this. So the container is sliding, okay? Find the angle made by the liquid surface with respect to the horizontal. Let's try this thing. Can someone tell me this first? What will be the acceleration of the container? If you keep a block on a rough incline, what will be the acceleration of the container? Now see, this is pure friction ka question. It has nothing to do with fluid. Can someone tell me that? You keep a theta, you keep a block of mass, and its acceleration kitna hoga?
G sin theta minus mu g cos theta.
Right? mg sin theta minus mu mg cos theta is ma. See, this is what I was saying. When I say your basics should be clear, if you get a question like this, the answer should just come out immediately. If you're struggling to tell me the answer of this, matlab wahi ho raha hai. You guys are not solving the HCV or booklet properly. So keep that in mind. When I say your basics are clear, this is what I'm expecting. I'm not expecting high-level problems. How do you do this thing? Try. I'll give 2-3 minutes. It's a good one. This and the example were the same thing. Only this thing, na, it will be g sin theta minus mu g cos theta. This will be the difference. The pseudo force will change. That is the only difference. Try. I'll give it 2-3 minutes. It's a good one. This would be mains for tough one and advanced will be an easy one. And see, I just taught you one definition till now. The liquid surface will be perpendicular to the net force. And net force you calculate with respect to the container, that is include the pseudo force. Rhythm, come on. Anyone confused with the question, please ask me. Try. Same thing. You know the acceleration, g sin theta minus mu g cos theta. The force will be mg sin theta, mg cos theta, pseudo force. So in theta ka resultant will look like this. That resultant ka perpendicular line draw karo. And I'm asking you this angle with the horizontal. I hope you're getting what I'm asking. Theta, nah, re. 6. Expression is g sine theta minus mu g cos theta. So if you write the forces on the system here, mg sine theta, the pseudo force will be mg sine theta minus mu mg cos theta, and this will be mg cos theta. So if you subtract them, what do you get the resultant as? Resultant will be mu mg cos theta. This will be mg cos theta. Agreed? The resultant of these two is mu mg cos theta on the forward direction. So the net force will be, this is F net, right? This is the incline. So the liquid surface would be perpendicular to whom? The black line, na? This is the liquid surface, which is perpendicular to this black line. Does everyone agree with that? And you have to find this angle here, alpha. Let's call it beta. And let this angle be alpha. What is tan alpha? Opposite side, which is mu mg cos theta by mg cos theta. So here we got tan alpha is equal to mu. If that is alpha, this angle will be 90 minus alpha. This angle will be alpha. Everyone agrees? If that is alpha, this will be how much? 180 minus theta. Sum of the three angles should be equal to beta plus alpha plus 180 minus theta should be equal to 180. So beta will be theta minus alpha, which is theta minus tan inverse mu. Check. If you see, the only concept I used is what? This liquid surface is perpendicular to F net. First, itna hi tha. After that, it is all geometry there. Please check the angles properly. Trisha, you're saying something. What did you do for? क्या हुआ ऋषि?
The liquid surface वाले part में I got confused.
ये clear है F net?
हाँ, yes.
तब का liquid surface should be what? Perpendicular to this na black line. So वही है ना black line. Green line is, so green line is a liquid surface. Sure. And the question क्या पूछा था? Find the angle between the liquid surface with the horizontal.
Horizontal, yes.
तो मैंने इतना extend किया, it will go and meet the horizontal ना somewhere.
Okay.
ये है ना beta.
हाँ, yes.
I just extended it till you go and touch the ground, so that I can draw a good triangle. Nothing much.
So could you show beta in the upper wala diagram?
Which
Well,
one?
Beta in the upper diagram.
Beta. I didn't understand.
So the beta angle, what angle
Beta
is
का.
it?
Beta is the angle made by the liquid surface with the horizontal, na? This is the ground, right?
Yes.
ये ground है.
हाँ.
So what is the question? Find the angle made by the liquid surface with the horizontal. Actually,
Yeah.
container is only till here. Right?
Okay.
I just extended the line outside so that I can draw horizontal.
Okay.
Got it? Container actually ऐसा ही होगा ना?
हाँ.
The container
So
will actually look like this, somewhat like this.
Yeah.
Got it? तो ये liquid surface है ना?
हाँ.
तो question is इसका angle क्या होगा? ये बीटा है ना horizontal के साथ. मैंने सिर्फ extend किया था.
Okay, so.
Got it? I didn't draw the full diagram here. I just took a part of it.
Okay.
Is everyone clear with that logic? What I'm saying? The container is actually somewhat like this. So ये green line है ना? ये surface था. But for our convenience, I just extended the line big so that you can clearly see what is the surface. Any doubts on this? Danya, clear na? Harsh, Rishi, got this? Riddhi, Trisha, clear? Anamay? Ishita? Amu, got this? Ritam, you need to keep your camera on. Ritam, clear, eh? Yeah. Next one. We have a container here. It's a cube. L by 2, L, and L. This thing is an open top container. So the top part is not there, it is open. So this is an half-filled cube. Then what you did, you suddenly accelerated this with container A. So case 1, A is equal to G by root 3. Case 2, A is equal to G. Case 3, A is equal to G root 3. So you're accelerating the container, gravity is there. Are you getting how it is? You have a container, you suddenly started accelerating. Draw the shape of the liquid. So how will the shape of the liquid look like? It won't be horizontal. Draw the shape of the liquid surface and find out how much water will spill out. How much water spills out? I hope the question was clear. If you look at this, right? Look at this thing. We have a container filled with water, are filled. So suddenly, if you stop, right, the acceleration will be what? If you suddenly stop, which way is the acceleration, front or back? If your
Back.
vehicle is going and if you apply brakes, acceleration kis taraf hoga? Back, no?
Back.
The pseudo force will be forward, no? That's why did you see the liquid got accumulated in the front? Able to see this is what actually happens in a water tanker. So it is actually more difficult to drive a tanker which is half filled than a fully filled because the center mass is continuously shifting. It will be pretty unstable. See how that water is. And the water is sloshing inside. But in our case, it is continuously going with the acceleration. So this won't happen. It's an equilibrium. This is just an engineering ka video actually. So if you see containers are actually designed like this. So now if it suddenly stops, the center mass won't shift as much as before. It will be more sloshing actually. That water settles on much faster. But okay, that is not relevant for us right now. How do you do this? I hope everyone got the idea, right? What will happen? The water will actually make an angle like this. It will be bent. Draw the shape of the liquid and the how much liquid will spill out. Try. Again, if you think about it, I just taught you one concept. The liquid surface is perpendicular to the net force. Bus. I didn't teach you anything. We can play around this much with this. Try. I'll give you a minute or two. Yeah, horizontal surface. It's the block is sliding on horizontal surface. If you're having your dinner, just leave me a message you're having dinner and then you can switch off. If you're not having your dinner, just keep your camera on. Or else I'll be just kicking you out of the classroom. Like the way Rhythm just got kicked out. You should actually install, pepper sprays on your screen. So when you're doing something, teacher gets angry, he presses a button there and the pepper spray will spray it on you. You need to devise some kind of evil torture devices like that. So online class, you get a feeling teacher is scolding me. Right? Arish is thinking, let's make something like this. Or we should make sure everyone has some younger sister or brother in the house. Someone is not doing something, we give them a call. We'll come and start beating you. That works. How to do? Help you? Let me show you for a general method, okay? Let's say this is the container, and if it is accelerating forward, how is the pseudo force?
Backward.
Backward. The gravity is downward. So the resultant force will be somewhere in the middle like this. This is F net. I hope everyone is getting the logic of F net. So your liquid surface should be perpendicular to this black line. So if you take this angle is theta, this is theta, this is theta. So tan theta will be MA by mg, A by g. Standard result, remember it up. Whenever the container accelerates with A, it makes an angle tan theta is equal to A by g. Now in our question, what did you give? A is equal to g by root 3. So what is the angle? 30 degrees. So how will the container look like? It looks like this, no? Where this angle is 30 degrees. Sure. So this height will be h1 and this side will be h2. How to find h1, h2? Angle 30 aa gaya. How to find h1, h2? Any ideas?
Trigonometry से difference in heights मिलेगा.
So वो तो करना पड़ेगा. So tan 30 will be the difference in height h1 minus h2 by L ना. एक इक्वेशन है, दूसरा कहाँ से आएगा? We got one relation between h1 and h2. We need one more equation. Where will I get the second one? Any ideas? Where will I get the second equation from? Volume conservation, na? Liquid won't spill out, right? Volume is conserved. Okay, Varanda. So what is the initial volume? L cube by 2, right? Half filled, right? What is the final volume? This thing is a trapezium. Half into area of the trapezium, h1 plus h2 by 2 into L into the side is L. Is this making sense? This is the area of trapezium into that length. That will be the volume of the water. Sorry. Yeah. Sum of the sides by 2 into L, na? Is this fine, everyone? So this will give you the second equation. From here, you can find h1, h2. How will it A is equal to G, this thing look like? 45. So this will look exactly here like this.
H2 will be 0.
H2 will be 0. How will G root 3 look like? Right, I'll give you a minute. G root 3 kaisa shape दिखेगा and how much liquid spills out. Now the liquid will start going out, right? Once you cross 45, liquid will come outside. Now liquid will spill. So how much liquid will spill out and how does the shape look like for G root 3? I hope the question was clear, everyone. Try. See, did anyone got the idea there? What is the angle? What is the angle? $60, right? How will you draw 60 degrees here? How will you draw 60? Problem kya hai na? You can't draw like this because the liquid will not be like this. So the only possibility is you can't change the height anymore. So you have to change the base. It will become like this. Some part will get exposed to atmosphere. There will be no liquid only. You're accelerating so fast, the bottom part will get exposed to atmosphere. So this will be L and this will be L by root 3. So liquid will start receding from the container. This is 60 degrees. Are you getting this? So if you look at this now, this is how the shape actually looks. I hope you're able to visualize. If you accelerate so fast, the container, right, this part is exposed to atmosphere. There's no liquid here. This is how it looks. So that formula tan theta A by G is still valid, but this is how it looks. So how much liquid will spill here? So V final will be area of the triangle half into side into the base into L. So the volume spilled will be initial volume minus final volume. Initial volume is L cube by 2 by L cube by 2. This much liquid will go out. Check. All clear with this? This is how 60 will look. So most people get confused, you know, they won't understand how to draw. They will think, okay, ये 60 कैसा होगा? मतलब you can't draw like this because this liquid will go outside. It becomes confusing. The idea is that you can't change the height, so you can change the base. Any doubts? Clear, na? Gauri, got this? Nanya? Abdi, got this? Shaurya, clear?
Yes, sir.
Abhiksha? Perfect. Next one. We have a container here, cylindrical container, which you're rotating with omega. Did you ever do this thing in the bathroom bucket of water? If you rotate, what will happen? You get a
बीच में
shape
से
like
खाली हो
this.
जाता है.
ऐसा shape बनेगा ना?
Yes,
You
sir.
get a bowl shape, right? So this radius is r, and that is rotating with omega. So ये bowl shape है ना? So find the equation of this curve. This is a rotating liquid. Liquid in a container rotates with omega. Let's get this thing. Any ideas? I'll tell you one thing. See, listen, in physics, right, 11th and 12th at least, whenever someone asks you find the equation of anything, that could be anywhere. Okay, we did this in optics once. Find the equation of the path of the light ray. Find the equation of the curve. Find the equation of the surface. Anything. If you say find the equation of something, curve especially, right? In physics, right, there is only one way. You know, mathematics, what is tan theta? Slope, dv by dx, right?
Yes.
So somehow get the tan theta in terms of y and x from physics, then use to integration. You're getting it? That is the only way. Somehow using physics, you have to calculate tan theta and then equal to dv by dx. If you remember this, we have done this in optics. Refraction mein. Do you remember this question? A light ray is incident at an angle, it will start bending inside. Find the path or equation of the light ray. देखो यहाँ पे क्या किया? We found mu sin theta is equal to this. We did dy by dx. We found from optics, and then we integrated it. The idea was always that somehow you have to get the tan theta in terms of y and x and finish it off. So here we have to use fluid mechanics to get it. So look at the surface here. This bowl shape you have. Let this point be origin. Let this point be x comma y. So that means this particle here is going in a circle. What are the forces acting on the particle? dm g. What is the acting on this thing? dm omega square x centrifugal force. Everyone agrees it is going in a circle. So what is the net force? This is F net, no? So your surface should be perpendicular to this. So this is the tangent, no? I hope are you getting it? The tangent to the liquid surface should be perpendicular to the net force, and this is theta. If that is theta, this is theta, and this is theta. So we get tan theta is equal to dm omega square x by dmg. dm will cancel. We get tan theta is equal to omega square x by g. And we know tan theta is nothing but slope of a tangent. Right, Git? You got it. That will be dy by dx is equal to omega square x by g. So we get dy is equal to omega square x dx by g. Integrate. Y is equal to omega square x square by 2g. This is a paraboloid. It's a three-dimensional parabola. It's called paraboloid. Check. That's how you find the equation. Have a look at this. Any doubts on this? I hope the concept was clear. And all these problems, we just used one concept. Net force is perpendicular to the surface. I didn't even teach you pressure, anything. But you can do pretty good problems. That's the basic concept. The concept is quite important. The net force is perpendicular to the surface. Any doubts on this? Anyone not clear with this? Please ask. Sure, go ahead. Next thing. So that is one concept, okay, the net force concept. Now, next thing, while studying fluids, see every chapter, right, there are certain things fundamental. For example, when you studied laws of motion, if you see, we are more interested in force and mass of a body. But in case of a fluids, right, mass becomes little bad because the density remains constant. Mass of the liquid can change with the container. So while studying fluids, right, generally what we do, we study density and pressure. Pressure and density are important. So in place of mass, we study density. In place of force, we study pressure. So first thing, density. Symbol is rho. Simple definition, mass by volume. Variation of density, temperature. What happens if you increase the temperature? If you remember this, we have done in thermal expansion. So the density, new density, will be the old density by 1 plus gamma delta T, where gamma is the coefficient of volume expansion. Because whenever you heat a liquid, what will change? Volume will change, right? Mass will remain same. So mass by volume, volume has increased. Previous page. Clear?
So that formula is actually V final equal to V upon 1 plus gamma.
V final equal to what?
V initial upon 1 plus gamma delta T only.
वही है ना. You
Okay.
said 1 by coefficient of volume expansion. I hope everyone remembers this thing. Na? Volume will increase by V into 1 plus gamma delta T. So mass by volume, so density decreases. Delta T is the change in temperature. So here, right, sometimes we use words like this, specific gravity. Specific gravity is nothing but density with respect to water. So if someone says specific gravity of gold is 19.3, meaning he is saying the density of gold is 19.3 times the water. And water ka density is 1000 kg per meter cube. So that's it. So specific gravity matlab it is density with respect to water. Clear? Easy? Now let's say a simple question. If two liquids of density ρ1 and ρ2 are mixed, case 1, you are mixing same volume of liquid. So two liquids of density ρ1, ρ2, same volume is mixed. Case 2, same mass is mixed. Find average density. Get it, easy one, there's nothing there. Two liquids of same volume are mixed, two liquids of same mass are mixed. Find the average density. Get it, I'll give you a minute, easy one. What is the first one? What is the average density ka formula? Anyone? What is the average density ka formula? What is density ka formula? Mass by volume. So what is average density? Total mass by total volume, right? So first case, it will be mass will be ρ1v plus ρ2v by 2v. So ρ1 plus ρ2 by 2. Second case mein, total mass is m plus m. Volume will be m by ρ1 plus m by ρ2. This will be 2 times ρ1, ρ2 by ρ1 plus ρ2. Got this? Mass by density will give the volume. Clear? Next one. That's about density. Next thing is pressure. Symbol is P. So why do you get pressure actually? If you actually think about it at a fundamental level, when a surface is immersed in a fluid, tell me one thing, if you immerse in a fluid, what happens? You can imagine yourself like this. Imagine you inserted, you went into the local train when it is fully crowded. What will people do to you? They'll crush you from every side, right? So in this case, the molecules, the same thing happens actually. At a molecular level, the molecules are continuously colliding with the surface. The molecules collide with the surface. So when you say air pressure, atmospheric pressure, what is happening? The atmosphere around you, right? The air molecules are continuously colliding with your surface, generating a force along the common normal. This force per unit area is called pressure. Meaning, if you have a surface like this, now look at the thing here. When the molecule goes and hits it, see, molecules will collide in an oblique collision. Huh? But tell me one thing, even in an oblique collision, how will the force be? Along the normal, isn't it? No matter how you collide with the surface, the force will be always along the normal. Does everyone agree with that statement? Because when you're colliding obliquely, the momentum will change in which direction? Only along the normal, right? If this is the surface, if a ball is hitting you here, force will be this way. Na? It doesn't matter what is your velocity. The force will be always perpendicular to the surface. So pressure is defined as the force perpendicular by the area. So in a vector way, you can write F is equal to P into A bar. So pressure is a scalar quantity. So this is the perpendicular force and that is the surface area. Getting it? So if you see, right, the meaning of this is, suppose if you say at this point pressure is P, if you take an area vector like this, the pressure will act perpendicular to the surface like this. So this force will be P into A1. Suppose if you take the area vector like this, remember area vector is perpendicular to the surface out of the plane. Yeah, area is a vector. अरे A cross B क्या किया vectors में? What is A cross B? Area of a parallelogram, right?
Yes, sir.
Which is what? Perpendicular to the plane, na? I hope you guys remember. A cross B in vectors is what? Area of a parallelogram perpendicular to the vector. It's a vector out of the plane. So area is a vector there. And this force will be F2. So if you see, right, pressure does not have a direction. The direction comes because of the area vector. Hope that makes sense. Then we also define one atmosphere pressure, 1 atm, which is nothing but 1.01 into 10 power 5 pascals. All right.
So the force vector will be in direction of area vector.
Yeah.
Okay.
Right. This can be also written as 76 centimeters of mercury column. I'm sure you studied this in chemistry. We will discuss about that in more detail later on in barometer. Then we also define something called a gauge pressure. What's a gauge pressure? Actual pressure of the gas minus atmospheric pressure. Did you ever went to this thing, petrol pump or something, they measure the air pressure, right? Tires mein. So what happens, right? When you put the device to measure the pressure in your tires, in this device, there's a membrane. So inside there's a pressure of the gas and there's an atmospheric pressure. Because of this, the membrane will stretch. That stretching of the membrane is calibrated into a pressure difference. Higher the pressure difference, more will the membrane stretch. So the device will always measure pressure with respect to atmosphere. It will never measure the actual pressure. So that is called gauge pressure. So example, if someone says gauge pressure is 5 atm, what is the actual pressure?
5 minus.
6, na actual pressure.
Acha, okay.
All clear with this? So, this definition we keep hearing, right? Pressure will always create force perpendicular to the area. Look at the statement. The pressure will always create force perpendicular to the area. It is wrong. It is the other way around. The force perpendicular to the area by area is called pressure. I hope you get the difference. They look the same, but they're not. Pressure is not generating force. Because of the force, you got the pressure. Clear? All got the idea? Let's see some questions on this. I hope you remember this. Water jet. We have a water jet, density rho. Area A, it is going with the speed u. And we have a wall here. Wall is also going with speed v. Constant speed. E is the quotient of restitution. And u is greater than v. Find the pressure acting on the wall. The water jet hits the wall and quotient of restitution is E, and the wall is going away with speed v. Let's get this. Yeah, this came from variable mass system, if you remember. Water jet problems. Try, this is a good one. How do you do this? I hope you remember we took a small dx and then we calculated the dp by dt and all that. Try. Everyone keep your cam on. Should I help you? I'll tell you one thing. See, there are certain words which you should always remember. Here, what is happening? V is constant. I told you something. If something is going with constant velocity, what are you supposed to do? If something is going with constant velocity, and if you're wondering where we did that, we did this in multiple places. But I think the first time you encountered this was here. Do you remember this thing? The point A was going with constant speed. What did you do?
Pseudo. We
You
have to
stand
stop.
on it. You stand on it. Because it is going with constant velocity, what will happen? It's an inertial frame, right? There's no pseudo force. Are you getting it? And this is not the first time, huh? Then you did this in optics also. Mirror was going with constant speed. What did you do? You went and stood on the mirror, isn't it? You're getting the theme here. Anytime the wall or the mirror or anything is going with a constant velocity, stand on it. Because if you stand with respect to the mirror, your life actually becomes more easy to observe. So here you'll stand with respect to the wall. So if you keep the observer on the wall, what will you think about the water jet?
U
What is the
minus
speed of the water jet now? U minus V, relative velocity. So if the water jet goes with U minus V and hits the wall, it will bounce back with what velocity? E times U minus V now. Everyone agrees? If you hit a wall with speed U, you'll come back with E into U minus V. So what is the change in momentum? Change in momentum will be, take a small mass here, dm, which is density area into the width dx. This will be dm into V final minus dm into V initial. So dm will be rho into A dx. V final will be minus because it is going backward. U minus V minus U minus V. This is minus I cap. This is I cap. So this will be minus rho A dx into U minus V into E plus 1. This is your change in momentum. So force will be dP by dt minus rho A dx by dt into U minus V into E plus 1. What is dx by dt? Relative velocity. So that will become U minus V into U minus V into E plus 1. And if you divide force by area, you get pressure, which is rho into U minus V whole square into E plus 1. Minus indicates direction, that is fine. Dx by dt is nothing but V relative, because x is the distance between the wall and this thing, which is U minus V. Check how we did this. Are you getting this? If you just stop the wall, your life becomes easy. Wall is moving, liquid is moving, it becomes very confusing. Stop the wall. It will be more easy to see from that perspective. Check, any doubts on this, please ask me. Everyone clear with this? Perfect. Then, same thing, we have a better version of this. What if we have a wall at rest? This time, send a water jet like this at an angle theta. E is equal to 1, so it will bounce also with theta. So speed is U, density rho, area A. Can you find the pressure on the wall? Let's get this. If you are hitting the wall at an angle theta, find the pressure acting on the wall. Try. Everyone should give it a try. Focus, everyone. Don't sleep. Dipanshu, don't put hand on your head. Sit straight. You're feeling sleepy, go wash your face and come. But focus, important chapter, but easier than rotation. Yeah, obviously, you have to take change in momentum along the normal. How do we do this? These all are momentum-based questions, right? Don't put your hand on the head. Keep your hand down. First thing you'll feel like sleeping. It will be a good support. And focus. How do we do this? See. We take a small piece here. dm. So what is change in momentum here? Change in momentum will be 2 dm u cos theta. Agreed? Only the horizontal components will change, right? The cos theta component will reverse, sin theta component will not change. So this will be u cos theta. This will be u sin theta. This will hit the wall and bounce. This will be u cos theta and this will be u sin theta. Only the horizontal component is changing. So force will be dp by dt. Now just be little careful here. There's a small trap here. By dt. Itna tak clear hai. So force will be 2 rho a u square cos theta. Now tell me one thing. What is pressure here? F by a, na? What is that a here? Pressure, when you say force by area, it's a force by area where the water jet hits, right? It is not the area of cross section. This is what is happening. See, when the water jet is hitting, even though this is a water jet, the water is actually spreading over to a bigger area. Are you getting it? The water is hitting a bigger area. Is that making sense, everyone? Just think about it. See, this is the wall. Let's say this is the water jet. So this point A here is here only, but this point B here will go straight and hit here, na? Isn't this spreading over a bigger area? So if this area is A, this is 90, this is theta, this will also be theta. This area will be A by cos theta, na, hypotenuse. Actually, if you look at this from the front view, it's a circle, radius R and radius R, but it will stretch in one direction. This will be R and this will be R by cos theta. This actually becomes an ellipse. You're getting, when you're hitting at an angle, only this line is stretching, no? This line is not stretching. Are you getting it? Only this angle, this line is stretching. This line is not stretching here. So the circular shape will actually go and hit like an ellipse. I think of like this thing, huh? If you take a a cucumber and if you cut it like this, what shape do you get? Ellipse, right? If you cut a cucumber like this, ये जो shape आएगा ये ellipse है ना? Where this radius will remain R only, whereas this radius will become R by cos theta, right? I hope you're able to visualize. Cucumber is a good example. Huh? Told you na. With food, though, you can explain quantum mechanics also. People will understand quite fast. Sure. So what should you take pressure as here? Force by area. Which area? A by cos theta. That is a catch here. So this will be 2 rho u square cos square theta. Be careful. Huh? It's a cos square theta. Most people at cos theta and come from the exam. Wo kya tha? Check it out. This is a good one. Water jet questions. Please check. Ask me if you're confused. So we can add here. Water jet is spreads over a bigger area. Clear? Any doubts on this? Rhythm, you have a problem with your cam, kya? Or are you just switching it off so that I have to keep telling you to switch it on and then I'll kick you out? You are playing a game. Then why are you not keeping your cam on?
Sir, but that total area of ellipse will be pi into that a cos theta into a na.
And so that is what? A by cos theta only, na God.
Okay.
If you're eating the finish of eating, na, from the beginning you kept your cam off. You can't keep eating for 1.5 hours, right? That's not called dinner. You should learn that from Reina. She just eats ice cream in 10 minutes and finishes it off. Right? So yeah. Even Randa was eating ice cream today secretly. But okay. Next one. Variation of pressure with depth. So consider a container. Let's say we have a container here filled with liquid. Did I show you that video of the lock cutting? I showed you last time, right? You can cut a lock through the water jet. Yeah. So if you take a cylinder like this, and if you consider a cylinder like this, so let's say this point is A, this point is B, and this point is C. So consider an imaginary cylinders. A, B, and B, C as shown. Let this height be HA. The atmosphere pressure is P naught. This height be HB. Density of the liquid is rho. Now, if I draw the cylinder here, and if you write the forces acting on this, see the forces, huh? This way, it looks like loss of motion. Pressure of A into area, your own weight mg, and this will be pressure at the bottom, PB into area. Since this is an equilibrium, you'll observe PB into area minus PA into area will be equal to mg. This will be PB minus PA into area. Mg will be density into area and the difference in height. HB minus HA into G. Area cancels off. We end up with PB is equal to PA plus rho G delta H. If we take A on the surface, PA becomes P naught, HA becomes 0. The formula becomes P is equal to P naught plus rho G H. This is your first formula. Okay, where H is the depth from the surface. The only problem is valid only when rho and G are constant. Check that out. We can also say dP is equal to rho G dH. This is the differential form. This, right? Use this if rho and G are changing, especially for integrations, basically. So the formula now P naught plus rho G H is valid only when the density and the pressure are equal. I think you can note down them. Clear, everyone? Now, if you take a horizontal cylinder,
So can you go back for a second? Done, sir.
all clear, na? Any doubts on this? Amu, clear? Deepanshu? Anamay? Geet? Rishi? Rishi is gone today for some reason. No, you're fine. Okay. Yeah, we can see you. We can see you. Rena is drinking cool drink. Let's see. Deepanshu is like full stretching, gymnastics kar rahe ho. People are so tired, right? Because of pressure. What happened? Why are people are tired today? Something happened? The last time we were discussing, na? Ye Sunday exam, whoever scores less, we will send them to Kisi Ka Bhai movie. You get free tickets for that Salman Khan movie. People are saying it was so hopeless, it's like a torture. Okay, some people didn't understand what I was saying. Bad joke. Shall we see? So this is a PC into area. And if you see this container, right, there's no acceleration horizontally. PB is equal to PC. Now here, see, we have an important statement here. What this thing tells you, right? Pressure varies only linearly. Pressure varies in the direction of net force. Which we call as vertical. See, when you say up and down, right, the whole concept of up and down is what? The direction of net force. And does not vary horizontally. Again, remember, net force means what? It includes the pseudo force. Let me give you some examples. See, when I say up and down, right, exactly what do you mean by up and down? Like we discussed this last time also. If you're standing on the North Pole, what is up and what is down? This is up, this is down. If you're standing on the South Pole, you stand
Down
like
is
this.
up and up is down.
So basically, this is down, right? So basically, what is down exactly? Toward the center of the earth, na? Because the earth is attracting toward the center, that is called down. Are you getting it? So the direction of the net force is down. So look at this, some questions, okay? Example. Let's say we have a container like this. We have a container like this. We have a container like this. All are same height. Huh? And we have 3 points here. A, B, C. Which has more pressure? Who has more pressure? Anyone? Same, right? Why? Think about it. The pressure depends on what? The height, isn't it? As long as the height is same, it doesn't matter what container you take. You could have taken even a shape like this. A semicircle like this. The height is same. Because see, the logic is this. Suppose if I take like this, if I go down straight, see pressure varies how? Only in the vertical direction, right? So let this is H1. It will not change. It will again increase H2. Not change, again increase, not change, again increase, not change, again increase, not change, again increase. End of the day, it depends on what? On the total height, isn't it? So in this case, PA is equal to PB is equal to PC is equal to PD. Depends only on the height. Make sense? All the same. Let me give you one more example. Let's say we have a container here completely filled with liquid. So if I take this point here, let's say 1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, and 0.8. 45 degrees, okay? And only the gravity is there. Like container is at rest. Radius is there. Who has the highest pressure? So can you tell me here what is down?
Towards the center.
This is down, right? This is your down, vertical. So who has the highest pressure here? The deeper you are, higher the pressure, right? So what is the deepest point here?
5,
Five,
P5. Then
6 and 4.
P4, comma 6.
these are horizontals, no? P6 and P4 are equal. Then
1 and
1 and 3. Then 2 and 8. And then last is P1. I hope all are clear with this. So what is the pressure difference between the highest point and the lowest point? How much is this?
so that is P7 equal to P3. No?
Yeah. What is the pressure difference between 1 and 5? Rho G, how much?
2R.
2R. All clear with this? Logic sums mein? Now look at this is not the actual question. Suppose the same question completely filled. This is 1, 2, 3, 4, 5, 6, 7, and 8. This time the container is accelerating with A is equal to G. Gravity is also there. Now can you tell me which will have the highest pressure? Try. Everyone should think. I give you 30 seconds. Think about it. Now, if the container is accelerating horizontal with A is equal to G, which point will have the highest pressure?
4.
No, Dipanshu. 4. Nair.
6.
How is the pseudo force? MA,
Oh no, sorry, 8, I think.
which is mg, na? How is the gravity? Mg downward. So what is the net force ka direction? Isn't this the net force? Which is root over m into root over a square plus g square. In this case, it is m into g root 2. Are you getting it? So this is down, huh? This black line is vertical. Means anyone in this container, right, they will think they'll stand like this, isn't it? They will think the world is at an angle 45. So what is horizontal here? These are horizontals, no? I hope everyone is getting this logic here. And what will be the gravity according to this? So the whole system will think the gravity has become G root 2. Is that making sense? G effective. So now you tell me, who has the highest pressure? P6.
6.
Right, Harsh? Then
7 and 5.
Then these two, no? 7 and 5. Then 8 and
8.
4. Then 1 and 3. And then last is P2. Clear? Are you getting this logic here? Up and down is totally a relative concept. It depends on what is your force. What's the difference between P6 minus P2?
Rho G2R.
Rho G effective, gravity has changed.
Huh.
So rho G root 2 into 2R. Don't forget that. Do have a look at this. It's a good example. Clear with this? Amo, got this? Everyone is clear what is up and down? Think about it. ये starting में जो problem क्या था ना ये container का. Why is the liquid becoming like this? Because the gravity looks like this, na? People will think the force is this way, isn't it? I hope everyone clear with the concept of down and horizontal. Any doubts on this? Anyone not convinced? This is not clear? Riddhi? Krishna, clear?
Sir,
Great.
if it starts rotating, then down will be something else.
Huh. And down will be something else. Let me give you one more example. Suppose if you have a cylindrical container completely filled, this is length L, this is length P, gravity is there, and the container is accelerating also. If this is 0.1 and this is 0.2, this is a completely filled rectangle. Can you find the pressure difference between P2 minus P1? This is like question and everything. How do you find pressure here? Unlike the previous question, right? Here, there is no guarantee the F net will pass through 1 and 2. Na? F net can be like this also. Are you getting it? There is no guarantee F net will pass through this. F net can be in any direction. So we don't know how that works. So how do you do such kind of problem? Think I'll give you a minute. A proper mains and bits level question here. See, any ideas? Now here what you can do now, travel like this first, take a cylinder like this, and then take a cylinder like this. And let's call this point 3. So when you take the horizontal cylinder, this is 0.1 and this is 0.3. Tell me one thing, for the horizontal cylinder, what it will think? It will think gravity has become A, na? It will think the gravity G effective is A. So we get P3 minus P1 is density into the gravity A into L. Everyone agrees? For the horizontal cylinder, we'll think the A is the gravity. Now when you take the vertical cylinder, this is 3 and this is 2, the gravity is G. P2 minus P3 will be rho B G. Are you getting? So basically, this is how you are traveling. Travel from 1 to 3 and from 3 to 2. When you don't know the exact directions and angles, you can travel like this. Travel opposite way and downward G. And now add them. P3 will cancel. P2 minus P1 will be rho AL plus rho BG. Check.
Sir, but when we will travel down from 3 to 2, we will also move sidewards now. So
Where? From?
when we move from 3 to 2, there is sidewards acceleration also, no? A.
Okay. But you're going which way?
Okay, down only.
And then? Why will the horizontal acceleration matter when you're traveling down, right? Is this easy, everyone?
Sir,
Uh,
so we can't use that tan theta equal to A by G from that and then assume X distance from A.
that is for what, Shaurya? Tan theta एवजी exactly किसके लिए? Tan theta एवजी किसके लिए?
No, means
Problem is what na, you remember the formulas, but you just mix up everything.
No,
Tan
sir.
theta A by G is for what?
No, sir. Here also at the center of mass mj we assume to be down and ma to be
Okay.
at the pseudo force.
Agreed.
Then the resultant at an angle theta.
I got that. Now उसके बाद क्या कर रहे हो exactly? Tan theta A by G. चलो उसके बाद क्या करने वाले?
हाँ फिर वो
करके मुझे
एक
वर्किंग भेजो ना. करके वर्किंग भेजो ना. Under the class we can discuss. करके भेजो. Let's see, have some idea. So let's see how it works. Let's see a question.
sir,
Let's
can you
say
show
we have a use. Any doubts on this? Please ask me the example.
yes sir done.
All clear?
Yes.
Let's say we have a U-shaped container here. Let's say the left side is filled with ρ1. The height is h1. The right side is filled with liquid ρ2. Height is h2. Find ρ1 by ρ2. Easy one. Same question, I can frame it like this also. We have a circular tube here. On the left hand side, we have liquid here. Till here, 90 degrees. This is ρ1. On the other side, we have this black liquid here. This is theta. This is ρ2. Find ρ1 by ρ2. Get these two. Get this one, everyone. Easy one. What is the catch here? The pressure at the bottom should be same. Try. I'll give you a minute. Everyone should try. Others, keep your cams on. Focus. Harsh, h2 by. Yeah, right, Harsh. First one is right. Second one. Keep going. See, the idea here is if you look at this point here, A, and if you look at this point here, PA should be equal to PB. Do you agree? If the pressure is not equal, the liquid will move. Similarly, if you look at this point here and look at this point here, PA should be equal to PB here also. So here PA will be P naught plus rho G H1. PB will be P naught rho 2 G H2. We get rho 1 by rho 2 is H2 by H1. Easy. Now here when you take, tell me one thing, for a container, for the pressure, what do you take? You are interested only in the vertical height. You don't actually need the length. So what will be this height here? R. What will be this height here? R into 1 minus cos theta, na? Is that clear, everyone? That is the catch in the question. So यहाँ पे pressure होगा rho 1 G R rho 2 G R 1 minus cos theta. The height on the left and the height on the right. So rho 1 by rho 2 is equal to 1 minus cos theta. Check. That's it. It doesn't matter what shape you take. You could have taken some random any damn shape like this. End of the day, what matters is this heights only. So that is one thing. Roamer and fluids, it only depends on the height. It doesn't matter what kind of the container you're taking. Check. Clear? Any doubts on this? Next one. So let's say we have a U-shaped container here. Filled with liquid. This is L. This is 2L. And this is L. Density is rho. What happened? Someone pushed this liquid by X down. And released. What will happen if you push the liquid on one side and leave it? Oscillates now up and down. Find the time period of oscillations. SHM. And fluid mechanics. Find time period for oscillations. So we have a U-shaped container. The height is L, 2L, and L. The base is 2L. You push the liquid on one side by X and you leave it. Find the time period of oscillations. Try. How do you approach this? Two pi mx by m rho g root. Okay. Now I have a question for you. If I push one side by X, what will be the difference in height? Anyone? If you push one side by X, what is the difference in height of the liquid on both the sides?
Cos theta.
थीटा कहाँ से आया रे? If you're pushing this by X down, ये ऊपर X जाएगा ना? So what is this difference? 2X, right? Are you getting it? If you push one side by X, the other side will go X up the reference line. So actually 2X liquid is up. So this liquid is pushing this 2X column is pushing the whole liquid down. This is the restoring force. So what is the restoring force? 2 times density, area, length into gravity is equal to mass into acceleration. What is the mass? Density, area, total length is 4L into acceleration. So rho A 2xg. Rho A will cancel. A is equal to minus xg by 2L. So this thing looks like minus t by 2L into x. That is your omega square. Time period will be 2 pi root over 2L by g. Please check. That's it. You get you displace it by x, find the restoring force is equal to ma. The story is still the same.
Sir.
Yep.
Sir, in that earth wala question.
Earth wala question.
Means जिसमें एक sphere जैसा था ना, इसके अंदर पानी भरा था.
Yeah.
हाँ सर, तो उसमें अगर हम रो GH लगाते हैं तो जो H लेना है उसमें हमें वो along the G effective वाली लाइन का लेना है ना.
Yeah.
Okay.
All clear with this? Easy. Can I turn the page, everyone? हाँ बोलो ना. How did you get दिया ना 12 L and L. Next one, we got a lake. You know, when you go under water and diving now, it is one of the most dangerous job. They pay you good, but it's a dangerous job. You have to be certified for it. सबको क्या लगता है ना, I'll just go under the water and breathe. तो क्या है? I'll put all that oxygen mask. हाँ, 5-10 meters, 20 meters चलता. After that, something actually happens. So let's see a question. So we got an air bubble here of radius r. As the air bubble comes to the surface, the radius becomes 2r. This is water, density is 10 power 3 kg per meter cube. Outside the pressure is P naught. This is height h. Assume temperature is constant. Find height of depth of the lake. So the radius of the bubble doubles when it reaches the surface. Doubles in radius when it reaches the surface. Find h. Get this. Is the question clear? Did you ever see this thing when these skydivers are there now, or this water divers? Next time see a video, okay? When the diver is coming up, you can see continuously the air bubbles are coming out. If you observe that thing, we will see why that happens. Try. Give you a minute. This is a good one. You want a hint? KTG and fluid mechanics. This is based on KTG and fluid mechanics. And yeah, pressure inside outside. Nahi see na. Temperature is constant means what? What process is this? Isothermal. So P1 V1 is equal to P2 V2. So what is the pressure at the bottom? Pressure at the bottom will be P naught plus rho g h. What is pressure on the surface? P naught. So this will be P naught plus rho g h into volume will be 4/3 pi r cube. This will be P naught into 4/3 pi 2r whole cube. 4 by 3 pi, 4 by 3 pi will cancel. So we get P naught plus rho GH will be equal to 8 times P naught. So rho GH is 7 P naught. Rho is 10 power 3, G is 10, and H and atmospheric pressure is 10 power 5. H will be 70 meters. So if you observe something, radius looks double, but the volume became 8 times, right? Now imagine, okay, you are a diver who took an oxygen cylinder and went to a depth of 70 meters. 70 is too high actually. Normally people can't go more than 30, 40. Anything more than that, you have to use a machine to send there. These underwater sea cables are there now. You have to, after putting them, you have to do welding and everything. Welding, gas pipelines and all that. So it's a pretty risky thing. So see what happens. Now let's say you're at a depth of 30 meters or 40 meters and you breathe oxygen from the cylinder. Okay? Now when you're starting to come up, what will happen to the pressure outside? Decrease. So what will happen to the air inside your lungs? They start expanding. So you have to continuously breathe out the air. By chance, if you just keep your breath tight, the air will expand so much, your lungs will explode. Exactly, lungs won't explode. You will just become unconscious and you will lose your breath. You're getting the problem. So that is the reason. If you see, right, this is one of them. They'll tell you for a diver. When you're coming up, you have to continuously keep pushing the air out of your lungs because it's expanding. This creates a lot of problems also for divers actually. At a high pressure, right? Did you ever see this Coca-Cola or something? When you open the bottle cap, suddenly the gas bubbles out. Observe that. When the cap is on, the gas doesn't come out. The moment you open, the gas bubbles out. The same thing happens also at high pressure, right? The oxygen and the nitrogen gas especially. See, when you breathe, right, oxygen gets mixed into the blood. That's how the transport. That is good. But nitrogen does not get absorbed. So when the pressure is high, the nitrogen gets absorbed into the blood. So when this guy comes onto the surface, right, the nitrogen starts bubbling out of your blood. You won't die, nothing dangerous, but the divers experience very bad pain, it seems. It will take 2 to 3 days to recover. So what they do in this divers oxygen cylinders, right, they mix oxygen plus helium. They don't use nitrogen. Because helium has a higher, it does not get dissolved in the blood easily. So you just can't use any gas cylinder and go into the water. They are very specialized ones. Clear? Easy question? Last one for the day. We have a tall container filled with gas. Temperature is T constant. Throughout the gas, the temperature is constant. Gravity is also constant. At the bottom, the pressure is P naught. For this gas, the molecular weight is m. So it's a tall container, so the gravity is constant. So find the pressure at a height h from the bottom. So if you're traveling above the atmosphere, find the pressure. Ideal gas, huh? Tall container filled with ideal gas at temperature T, molecular weight m, constant gravity. The pressure at the bottom of the container is P naught. Find the pressure at a height h. Get it? This is another standard question. Let's finish off last one for the day. KTG, fluid mechanics. What is the catch here? For an ideal gas, what is the equation? PV is equal to nRT. Can I write this in the form of density? P is equal to rho by mRT. And we also know one more relation. What is dP? dP is equal to rho g dH, but we'll use a minus sign. Why? Because normally h should be depth. Here h is height instead of depth. That's why we put a minus sign. So take rho from here, Pm by RT, and substitute here. So we get dP is equal to P into M into G by RT with a minus sign into dH. So we get dP by P is equal to minus mg dH by RT. Everyone should definitely solve these problems, all these again before next class. At the bottom pressure is P naught, this is P, and this is 0, and this is H. This will be ln P by P naught minus mgh by RT. So pressure P will be P naught into e power minus mgh by RT. That's how the pressure varies with height. That's an exponential function. We did almost 9 questions, everyone. Do make sure to revise, take a rough paper, each and every question try to resolve. You're still not clear, somewhere there's a confusion, do ask me in the next class. Okay, so make sure to do that. Don't forget it, and start doing your SHM. Don't wait anymore. Start solving. If you're doing HCV, definitely do the examples, do objective and objective 2, and then start the exercise. That will help a lot. Don't directly jump into exercise. You'll get stuck. You can refer the notes once, do the examples, objective and objective, and then start the exercise. Okay, so we will wind up for today with this. So next class when we meet, we'll continue from here. Like I said, the chapter, if you see, right, there are very few new things actually. What did you learn? Force is perpendicular to surface. Uske baad kya, what did you learn? Rho is equal to dP is equal to rho g dH, isn't it? That's it. After that, everything else is loss of motion and all that stuff only. Okay, so with that, we'll wrap up. So any doubts, anything, please stay back and ask. Also free to leave. So make sure to resolve and come for the next class. And I'll catch up on Friday as usual. So take care, stay safe. I'll see you on Friday.